This section is going to focus on three things. You need to be able to work out the solubility of different compounds, different salts. You need to be able to tell me how to prepare an insoluble salt, and you need to be able to tell me one particular example how barium salts are used in health. For example, if you were to have a look at these three compounds, you need to be able to tell me which ones of those are soluble, will dissolve in water, and which ones are insoluble, will not dissolve in water. To do that, you need to be able to use this table. The first thing you need to do is have a look at the last parts of the salt. So in this case, we go with copper sulfate here. So have a look down your list for the sulfates, and you can see that most sulfates are soluble in water except for lead sulfate, barium sulfate and calcium sulfate. That means that copper sulfate is soluble. If we have a look at sodium hydroxide, most hydroxides are insoluble in water except for sodium hydroxide, potassium hydroxide and ammonium hydroxide. Therefore, sodium, being one of the exceptions, is soluble. Copper hydroxide, however, is insoluble. In the example that I'm going to show you in a minute, I'm going to react two soluble solids together, sodium hydroxide and copper sulfate, and I'm going to produce an insoluble solid, a precipitate. To be able to name the products, it's nice and simple. All you need to do is swap the names around. So if I react sodium hydroxide and copper sulfate together, all I need to do is take the copper and the sodium names and swap them round. So I'll get copper hydroxide and sodium sulfate.
Today I'm going to show you how to produce an insoluble salt. You need to start off with a solid that is a salt that will dissolve in water. So copper sulfate is one example, which when dissolved will form a liquid copper sulfate. I'm going to react it with sodium hydroxide to produce copper hydroxide and sodium sulfate. When you react these two chemicals together, a precipitate will form. A precipitate is an insoluble solid. In this case, it is the copper hydroxide. The next thing you need to do is filter your solution. So get yourself some filter paper and a conical flask and a filter funnel and tip through your solution. Once filtration is complete, you need to be able to wash the precipitate. To do that, use distilled water. What you're doing here is getting rid of any of the liquids that hadn't fully reacted. So any of the leftover copper sulfate, any of the leftover sodium hydroxide, and any of the sodium sulfate as well. This will leave you with a pure sample of your copper hydroxide. Once you've filtered it through and washed it, remove it and place it onto a cloth to dry. Once it's dry, you will have a solid precipitate of copper hydroxide.
As you can see from this, the copper hydroxide is insoluble and the sodium sulfate is soluble. So the precipitate that you make in this reaction is copper hydroxide. One of the things you might be asked about in the exam is barium meals. The first thing you need to know is how to prepare barium sulfate. So you can take two things, for example barium nitrate and potassium sulfate, and react them together. If you do that, swap the names around again, you get potassium nitrate and barium sulfate. If you have a look at your solubility table, you can see that most sulfates except for barium sulfate are soluble, so barium sulfate is insoluble, and all nitrates are soluble. So the precipitate you're going to form in this reaction is barium sulfate. Barium sulfate is used for X-rays. Normally only bones show up when you have an X-ray. However, barium sulfate, being a precipitate, is opaque. You can't see through it. Therefore, when you drink it, it shows up in the gut, so if there are any problems, any blockages, that will show up on an X-ray. However, they are toxic, but barium sulfate can be safely drunk because it's insoluble. It means it isn't absorbed into the blood, it just passes through the body. So when a patient drinks it, it's known as a barium meal, and it shows up on the X-ray to tell you if there are any blockages.